In this video, we're going to go ahead and take a look at some examples from the homework in section 5.4 on sampling distributions and the central limit theorem. Let's go ahead and take a look at the first question, and it says that a population has a mean of 89 and a standard deviation of 24. And we want to find the mean and standard deviation of a sampling distribution of sample means with a sample size of n equal to 36. Okay, so to answer this question, all we need to know is that the mean of the sample means is equal to the population mean. Okay, so this is the symbol we use to represent the mean of the sample means, and then this is the symbol for the population mean. So it's just saying that the mean of the sample means is the same as the population mean. So likewise, the standard deviation of the sample means is equal to the population standard deviation divided by the square root of the sample size. Okay, that's given by this formula. So the standard deviation of the sample means is represented by this formula here, or this symbol here, sigma x bar. And according to the formula, sigma x bar is equal to the standard deviation of the population divided by the square root of the sample size, n. Okay, so the mean of the sample means is going to be the same as the population mean. So the answer to the first part is 89. Okay, to figure out the standard deviation of the sample means, we apply this formula. So we take the standard deviation of the population, okay, which is equal to 24, and then we divide it by the square root of the sample size, and the sample size is 36. So on our calculators, we can type in the number 24, okay, and then divide by the square root of 36. Okay, so 24 divided by the square root of 36 is equal to 4. So the standard deviation of the sample means is equal to 4. So before we move on, notice how I typed it into the calculator. So I typed in the standard deviation of the population first, then hit the division button, and then I typed the number 36, and then followed by the square root button. So in this calculator, when you want to do the square root of a number, right, you type in the number first, and then hit the square root button. Okay, on other calculators, you may have to do it the other way around, right? You type in the square root function first, and then type in the number you're taking the square root of. Okay, so depending on your calculator, you may need to type that in a little bit differently than I did. But in any case, you should be getting 4, right, if the population standard deviation is 24, and the sample size is 36. And of course, you can do that separately. You can take the square root first, and then divide that by your previous answer. Okay, so let's go to the next question. Alright, so number 2 is very similar, but only the numbers are different, so I'm going to go ahead and skip it. Alright, so number 3, it asks us to find the probability and interpret the results. And if convenient, we're going to use technology to find the probability. So let's go ahead and read the question. So the population mean annual salary for environmental compliance specialists is about $61,000. A random sample of 38 specialists is drawn from this population. And the question is, what is the probability that the mean salary of the sample is less than $57,500? And it says we're going to assume that the standard deviation of the population is equal to 5,600. Okay, so what says the population mean is, okay, that's your population mean, which is 61,000. And then it says a random sample of 38 specialists. So a random sample of blank, right, would be your sample size. So n equal to 38 is your sample size. And we want to know the probability that the mean salary of the sample is less than 57,500. Okay, so remember, we are supposed to apply the essential limit theorem when necessary. Okay, so we don't know anything about the distribution of the population, right? Whether the population annual salary of these compliance specialists is normally distributed or not normally distributed. But the problem doesn't say. Okay, so then you check to see if the sample size is large enough. So remember, the central limit theorem says that if the sample size is at least 30, right, then the distribution of the sample means will also be normally distributed. Okay, so because the sample size is 38, okay, which is greater than or equal to 30, you can assume that the distribution of the sample means is normal. So to answer this question of finding the probability that the mean salary is less than 57,500, we're going to be using the normal distribution calculator in StatCrunch. Alright, so in order to do that, we need to find the mean of the sample means and the standard deviation of the sample means. And according to the book, the mean of the sample means is equal to the population mean. Okay, so the mean of the sample means is equal to 61,000. So we'll go to StatCrunch, the stat menu, calculators, and the normal. Okay, we're going to replace the mean with 61,000. Okay, and the standard deviation is going to be equal to the standard deviation of the population divided by the square root of the sample size. Okay, so in other words, when we input the standard deviation, right, it's not the standard deviation of the population, but it's the standard deviation of the sample means. So, going back to the problem, the standard deviation of the population was 5,600. So what we do to get the standard deviation of the sample means is we take 5,600 and divide it by the square root of the sample size. Sample size is 38. The square root of 38 is that number, so the calculator is going to know to do 5,600 divided by this number. Okay, and the resulting number is the standard deviation of the sample means. And let's go ahead and round that to 2 decimal places, so it's 908.44. Okay, and we want to know the probability that in a random sample of 38 of these specialists, the sample mean is less than 57,500. Okay, so less than means we're going to select the less than or equal to symbol. Alright, and then type in the number 57,500 in this box here, and then click compute. And then the probability will go in this box. Then we're going to round our answer accordingly, so we want to round it to 4 decimal places. So 4 digits after the decimal point. Okay, so this is the 0 in the rounding position, and the next number over is 5 or more, so 5. Okay, so that's 0. 4 digits after the decimal point gets rounded up to a 1. Okay, so the probability is quite small. So 0.0001. So remember, this is 0 is getting rounded up to 1. So 0.0001 would be the answer. Okay, and then it's asking us to interpret the results and then choose the correct answer. Okay, so notice how these answer choices are worded very similarly. Okay, so they each start off with only blank percent of the samples of samples of 38 specialists will have a mean salary less than. So they all kind of say the same thing. What we want to do is convert this probability. Okay, so 0.0001 into a percentage. Okay, so we're going to use the rounded value, so 0.0001. All right, and when you convert a decimal to a percentage, you move the decimal point 2 places to the right and attach the percent symbol. Or in a calculator, type in that decimal and multiply it by 100. Okay, so you get 0.01, so it's actually 0.0% of samples of these specialists will have a mean salary less than 57,500. Okay, and that's quite a small percentage, right? It's 1/100th of a percent. It's a very, very small percentage. Okay, so it's very, very unlikely that if you get a random sample of 38 of these specialists, it's very, very unlikely that their mean salary, the mean salary of the sample, will be less than 57,500. Okay. So we know that decimal 0.0001 as a percentage is 0.01%. Okay. So answer choice D looks like the best choice. So about 0.01% of the samples will have a mean salary less than $57,500. And remember, that's a very small probability. So it's between A and D, right? So that's actually very unusual. Okay, so it's actually answer choice A. Now, if the probability was higher, if it was higher than 5%, then it would not be unusual. But because it's less than 5%, in fact it's very small, it's an extremely unusual event. So answer choice A is the best answer choice. Okay, so let's go to look at question 5, and it says that the mean height of women in a country ages 20 to 29 is 64.4 inches. Okay, so that's your population mean. A random sample of 65 women, so 65 is our sample size, in this age group is selected. What is the probability that the mean height for the sample is greater than 65 inches? Okay, so don't confuse our sample size, which is 65 women, with the height here of 65 inches. Like you can easily confuse it. Okay, so those are different. All right, so we want to find the probability that the mean height. So this question is about the probability that the mean height is greater than 65 inches, and we're assuming that the standard deviation of the population is 2.99. Okay, so when we input this into our calculator and StatCrunch, right, the mean of the sample means is equal to the population. Okay, so the mean of the sample means is equal to 64.4, which is our population mean. So 64.4 is the mean. Okay, now how about the standard deviation of the sample means? Okay, so remember that's equal to the standard deviation of the population divided by the square root of the sample size. Okay, so we're going to input that into our calculators. So 2.99 divided by the square root of 65. Okay, and this number here, so 0.370. Let's go to round that to 3 decimal places. So usually 2 to 3 decimal places for the standard deviation of the sample means is sufficient. Okay, so that 0 is going to get rounded up to 1, so 0.371 is our standard deviation. Okay, and we want to know the probability that the mean height for this random sample of women is greater than 65. Okay, so we're going to select the greater than or equal to symbol, type in the number 65 here, click compute, and the corresponding probability will appear in this box. All right, and it shows you the probability inside the normal curve, shaded in red. Okay, so rounded to 4 decimal places. Okay, the probability is 0.0529. Okay, and that completes question 5. Thank you for watching.